After years of anticipation, Blue Origin's heavy-lift orbital launch vehicle, New Glenn, achieved its maiden flight on December 16. The launch took place from Launch Complex 36 at Cape Canaveral Space Force Station in Florida. Liftoff was smooth, marking the beginning of what was described as a normal ascent phase. The rocket soon achieved max Q, the point of maximum aerodynamic stress, and continued its journey into space. The first stage engine cutoff occurred on schedule, followed by the successful separation of the stages. The second stage engines then ignited, pushing New Glenn towards its target orbit. Attention soon shifted to the ambitious recovery of the first stage booster, which aimed to land on Blue Origin's drone ship, Glen, stationed 620 kilometers offshore in the Atlantic Ocean. During re-entry, the booster initiated its planned entry burn, relighting 3 engines to decelerate. However, the mission encountered a setback when the booster experienced an anomaly during its descent phase. Telemetry was lost after the entry burn, and initial reports suggest the stage did not survive re-entry, likely disintegrating in the atmosphere.
Trying to get all of the data here, we seem to have lost telemetry on the first stage. We very well may have lost the booster. We are still coming in with all of the information. I want to make sure that we get you the right information.
While the exact cause remains unclear, an investigation is underway to identify the failure points. Despite the booster's loss, the second stage continued its mission without disruption, reaching a highly elliptical medium Earth orbit about 80 minutes after liftoff. On board was the Blue Ring Pathfinder, a prototype orbital space tug and satellite platform designed to showcase Blue Origin's advanced in-space capabilities. The Blue Ring multi-mission space mobility platform is envisioned as a versatile spacecraft for satellite servicing, hosting payloads, and facilitating in-space transportation. It is marketed primarily as a space tug capable of delivering satellites to precise orbits, including challenging destinations like geosynchronous orbits, Lagrange points, cislunar space, and potentially even interplanetary trajectories. Additionally, the spacecraft is designed to perform satellite servicing tasks, such as refueling, which can significantly extend the operational life of satellites. The total payload capacity of Blue Ring is up to 3 tons, varying based on the mission's target orbit. This flexibility allows it to cater to both small and large satellite deployments or maintenance missions. After reaching orbit, the upper stage of New Glenn did not release the Blue Ring Pathfinder, as the mission's primary goal was to serve as a test flight. Instead, the spacecraft stayed attached to the stage for approximately 6 hours, conducting detailed tests on telemetry, communications, and control systems. Following the completion of these tests, the upper stage and the Pathfinder spacecraft re-entered Earth's atmosphere, marking the end of this demonstration mission. With this launch, Blue Origin joins a select group of companies to achieve orbit on their first attempt. Despite the setback with the booster recovery, the successful insertion of the second stage into orbit demonstrated the capabilities of New Glenn in terms of power and reliability for payload delivery into space. While the next New Glenn launch has not yet been scheduled, the company remains committed to certifying the rocket for national security launches and expanding its role in commercial spaceflight. Founded by billionaire Jeff Bezos in 2000, Blue Origin has long harbored ambitions beyond suborbital tourism. In September 2016, the company unveiled its plans for the New Glenn rocket, a project that began taking shape well before its public announcement, with key components like engines in development since around 2012. The rocket is named in honor of John Glenn, the first American to orbit Earth, reflecting Blue Origin's aspirations to expand beyond the suborbital capabilities of its New Shepard vehicle and establish a significant presence in the orbital launch market. The New Glenn rocket towers at an impressive 98 meters, equivalent to a 30-story building, and features a 2-stage design, although earlier concepts included a third stage. Its 7-meter diameter allows it to house a significantly larger payload fairing than the typical 5-meter class rockets, enabling it to transport approximately 45 metric tons to low Earth orbit and 13 metric tons to geostationary transfer orbit. New Glenn's design incorporates advanced materials such as aerospace-grade aluminum and carbon composites. These materials were carefully chosen for their structural efficiency and lightweight, ensuring that the rocket remains durable while optimizing performance. Propelling the first stage are 7 BE-4 engines, which utilize liquefied methane and liquid oxygen. Each BE-4 engine can generate up to 2.4 meganewtons of thrust with a sea-level specific impulse of about 340 seconds, competitive within its class. These engines operate on an oxygen-rich staged combustion cycle, which optimizes efficiency and performance, collectively delivering over 17.1 meganewtons of thrust at liftoff. The B-4 engine is the result of over a decade of rigorous research and development. The first B-4 engine was fully assembled and underwent testing in 2017, marking a significant milestone in Blue Origin's engine development efforts. Since then, more than 100,000 seconds of cumulative testing have been conducted, ensuring the engine's reliability and performance. Notably, the BE-4 also powers the United Launch Alliance's Vulcan Centaur rocket. During its maiden flight in 2024, the BE-4 demonstrated its capabilities, solidifying its status as a reliable propulsion system for a variety of applications. One of the standout features of New Glen is its reusability. Post-launch, the first stage is designed to execute a controlled landing on a mobile platform in the Atlantic Ocean. This stage employs aerodynamic control surfaces for stability during descent, and includes 6 hydraulically actuated landing legs for touchdown. Remarkably, the first stage is engineered to endure at least 25 flights with only minimal refurbishment, significantly cutting down the cost of space access. The second stage of New Glen is powered by 2 BE-3U engines that utilize liquid hydrogen and liquid oxygen, providing over 1.5 meganewtons of thrust in a vacuum. The BE-3U is an evolution of the BE-3 sea-level engine, which has been successfully used on the New Shepard rocket since its first test flight in April 2015. The BE-3U was selected for the second stage after Blue Origin decided in 2018 to discontinue the development of the vacuum-optimized version of BE-4 due to delays. Looking forward, Blue Origin is exploring reusability for this upper stage under Project Jarvis, which aims to further reduce operational costs. Project Jarvis is a direct response to SpaceX's fully reusable Starship design, which has set new benchmarks in cost efficiency and operational scalability. The development of the New Glen rocket was a massive undertaking requiring significant investment in research, engineering, and testing. Blue Origin's state-of-the-art facilities in Kent, Washington, served as the primary hub for the rocket's development, while its extensive testing grounds at Launch Complex 36 in Florida provided the ideal environment for testing and refinement. Despite these advanced facilities, the project faced several delays, largely due to the complexity of developing the rocket's engines and adjustments in payload requirements. These challenges, however, were necessary for refining the rocket's performance to meet the ambitious goals set by Blue Origin. The latest successful test flight of New Glen marked a significant milestone in the rocket's development. With the completion of this test, New Glen is now closer to being ready for future missions, including carrying payloads to various orbits and, eventually, sending astronauts into space. Future goals for New Glen include supporting Blue Origin's vision of a space economy where millions of people live and work in space, similar to SpaceX's ambition for Starship to facilitate interplanetary travel. Apart from that, New Glen is poised to serve a diverse array of missions, from satellite deployments in various Earth orbits to ambitious expeditions to Mars. With its combination of high payload capacity, advanced engine technology, and reusability, New Glen offers a competitive edge in the commercial launch market.